So we have today you're Julia? Julia, yeah.
Julia.
So we have Julia Wagemann, and she's going to present 5 guiding principles to make Jupyter Notebooks educational and reusable.
Thank you, and also welcome everyone. As said, my name is Julia, and today I would like to share with you a synthesis of the last 4 to 5 years training Earth observation users on Earth observation data and climate data. And this work is on behalf of the colleagues that are also listed here. So just as a background, the learnings we have are from teaching users in Earth observation, remote sensing, and climate sciences. I'm an avid user of Jupyter Notebooks since 2014. And since 2019, I have developed more than 120 educational notebooks on open Earth observation data handling, access, visualization, and also machine learning. The trainings I'm involved in range from short webinars, mostly 1 hour to 1.5 hours, but also can be up to a week-long training schools. And sometimes there's also massive open online courses where then thousands of users or learners access the learning content. So with the training I'm involved in, so traditionally people or users from Earth observation data, they start with using satellite data at university level. But then, for example, in Europe, we have a large Earth observation program which is called Copernicus. It started in 2014, and it produces terabytes of data every day to be used. And so we also have an increasingly amount of training that is coming not only from universities but also from data providers itself, because we want users to use the data and to also learn how to use the data. And so there are some particularities if we have a look on the training, if we compare it with the training I'm involved in with academia or universities. So first we have a limited time. So we have limited instructor time and also limited time of setting up the programming environment. So if we have a webinar of 1 hour, for example, there's no time to do this. Then there's a very diverse training audience. So often we don't know what are the pre-knowledge and the basic coding experiences from the learners and participants in the trainings, and also what is the experience in remote sensing and handling these complex multidimensional data, and also the knowledge on how this data can be also applied and used for specific thematic applications. And then we also need a flexibility of how the content is taught. This is probably not different to university. So we have to have a flexibility online versus in-person training, and also instructor-led versus self-paced. So where we are at the moment, so I think this is no news in this community here, that so I read actually in one of the Nature publications in 2021 that there are more than 10 million Jupyter Notebooks available on Github, but yesterday we learned there's 2.8 million, but anyways, we have a lot of notebooks available. Within 10 years, we can say that Jupyter Notebooks, they became the de facto standard for data exploration, analysis, and training. And they used for research experimentation, development of machine learning pipelines, but also education. And this is a very important aspect. So it is used a lot to train data scientists and to use data, etc. But what is the state of these notebooks on GitHub? So are these 2.8 million notebooks available for us to use, and do we understand the code and the data, and everything can be reproduced and reused? And so I did a bit of research of notebook research in the past years, and I did a literature review in the last year. And I would like to share some of the findings I found there with you today. So the first pitfall and challenge a lot of critics of Jupyter Notebooks say is that we have an out-of-order execution of code cells, and this fosters poor coding practices. There has been an entire JupyterCon talk in 2018 on this, and if you're not aware of it, I really recommend to go back to the talk from Joel Gruss. But anyway, so the number one challenge is that, notebooks, they foster poor coding practices, because usually if you develop a workflow, you start at the beginning, but then you execute something more on the bottom, then you see there's a problem, then you go back, then maybe you add some code, you execute it again, and then you go back again to the bottom. And then often these notebooks are pushed to GitHub, and so often an inline execution doesn't work in the end. The second one is that there are challenges to make notebooks reproducible and reusable. And so I would like to ask you, what do you think, how many notebooks from, I just want to give you a bit of background. So there is a study from Pimentel et al., and I can really also recommend to read this. They analyzed all the notebooks on GitHub on whether they can be executed, and also how many of these notebooks are then also reproducible. So are they able to reproduce the same result as the authors say? And so here a question on the first one. So how much percentage do you think can be executed on GitHub? Who thinks it is more than 50%? Okay, so not very optimistic. So who thinks it is between 25 to 50%? Okay, some optimists we have here. And who thinks it is less than 25%? Okay, so the majority. So it is actually 25%. So 1 out of 4 notebooks can be executed on GitHub. And then the second one, so how many notebooks can actually reproduce the result? So who thinks it is more than 50%? No. So maybe we go a bit lower. So who thinks it is between 20 and 50%? Okay. Who thinks it is less than 10%? Okay, so yeah, in the end, it is really very low. So it's only 4% of notebooks that also produce the same result. And then a third challenge or pitfall is that even though notebooks should or they facilitate the combination of code and text and description of what we are doing, annotations and descriptive text is not evenly distributed within a notebook. It often starts very well at the beginning, and then at the end there is hardly any text. Then we also, it often resembles more like a spaghetti code and a collection of loose scripts than really a narrative and a step-by-step workflow. And a lot of notebooks, they have by far more code than any text cells. So all these findings in the Jupyter or computational notebooks community, they have led to the definition or the need to define best practices. And there have been the definition of quite a few best practices on how to write and share notebooks, how to make notebooks reproducible, how to foster collaboration, and how to use notebooks in academic classrooms. And I linked all these studies here, so if you're interested in best practice of Jupyter notebooks, then you have a collection here of really interesting articles. And so that's why I want to say the 5 guiding principles. What I share with you today is not that we are reinventing the wheel. These principles are founded in recognized best practices from the fields of scientific computing and Jupyter notebook research. And so we selected these 5 guiding principles on their applicability for training, specifically for training and capacity building. So these guiding principles have been mainly emerged from a training course I've been involved in from the beginning. So we started to develop this training course in 2019, and it is a training that consists of more than 70 notebooks that has different modules on how to access data, because with Earth observation data, it is not very simple because it's a very scattered landscape. So we have to showcase different systems, how to access the data, how to discover data. So how are they structured? Because they often come in different data formats and also different data arrangements. So we also have to showcase how the data can be handled, and then also case studies, so for what the data can be actually used for, and also exercises. In this course, this covers 6 different satellite products and 5 different model-based products. And the particularity of the course is that we also developed a set of reusable functions, which is a collection of functions that help us to reapply a specific set of code to visualize and handle data throughout the different modules. And we use this training to teach since 2019, and we taught over 2,000 learners and trained in 41 training events. And so the 5 guiding principles we emerged from our experience is first, leverage the literate programming paradigm. The second is to use instructional design elements. The third one is to follow best practices for scientific computing. The fourth one is take advantage of the full Jupyter ecosystem. And the fifth is aim for reproducibility. And these guiding principles, if you're interested in more content and also our reasoning why we think these are the 5 guiding principles, there is a published paper in remote sensing on this work. So I will now go through each of these 5 principles a bit more in detail. So the first one is the leverage the literate programming paradigm. So we could assume that the literate programming paradigm or computational thinking has been defined or started also when Jupyter Notebooks appeared, but in principle the idea is actually not new. So this was already defined by Donald Knuth in 1984, and just Jupyter Notebooks really brought also a tool where we can leverage this literate programming paradigm. But our users of Jupyter Notebooks, do they really leverage this possibility? And there are 2 other studies here which I would like to highlight. So one analyzed over 1 million notebooks on Github, and then the other one analyzed more than 1,000 notebooks. And so the first study there, they found out that out of 1 million notebooks, only 1 out of 4, like 25%, they had no text at all. So it was just code. And then the other study found out that when they analyzed more than 1,000 notebooks, is that the median text-code ratio, so the comparison between text cells and code cells is less than 1. So this means that we have much more code cells than any descriptive text. And so this was the motivation that we used our 70 notebooks from our training, and we also analyzed the ratio, the text code ratio. And so you see this in this table a bit more detailed for each module, but in average, the notebooks we developed and which we believe follow at least an educational and literate programming paradigm, they have around 3 times more text cells than code cells. Then the second principle is use of instructional design elements. And so here is just an example on how we leverage HTML and Markdown functionalities to really also make the learning experience nice. Because I personally don't like just going through any code and not understanding what the author did. And so we really try to also help the learner to navigate through the notebook. Not only, so we help them to navigate within a notebook, so to break it down in different workflow steps, but also we help them to really navigate through a set of different notebooks. And so here we just, so for example, we use also alert boxes for exercises, for making a specific content colorful, so to highlight something. We use a navigation pane that lets the learner to navigate from one notebook to the other and also back to the index. We use often also highlighting text as code, just to highlight specific content, and important to use use anchor links. So each notebook also has a outline and a table of content that helps the learners to jump also to specific workflow steps. So as an example, I can just showcase here. So this is the learning tool for Python. I added here in NB Viewer. And so we have an index page where we give information about the training. And here is like it is organized in different modules on data access, data exploration, case studies. And so here, basically, if you then click on it, and then it helps you to jump to specific content sections. And so if you open a notebook, then you have here a navigation pane that lets you go back to the index or to the next notebook. It also shows you relevant other content which uses the same set of data, for example. So this is an introductory or explorative notebook, and then we link also case studies where this data is basically used. And so we have a outline, and then this outline. So, for example, if someone is only interested on the third part, then they can directly jump there, and and this is helpful to navigate. So I go back. No. Can I go back here? Yeah. Okay. Good. So then the third principle is to follow best practices for scientific computing. And so this is probably not specifically for training and education, but it is specifically of interest, because if you develop notebooks for training, then you're also like the notebooks, they should be role models, and they should showcase how it is best done. And so this includes, for example, modularization of code, even though there's always a compromise to be made when you train when you can modularize a code, and when it is best to also leave it in the workflow, because to modularize everything, it's probably also not the best for training. But so, for example, what I said, like one part where we modularize code is with visualization and data handling libraries or functions. So we bundle these functions into an external notebook. It can also be a Python script. And then these functions, they are applicable to quite a few data sets in the training, and then they reloaded and reused again. And this helps us at the same time to cater for different coding expertise. So we have some pro coders, and then we always invite them to have a look to the functions notebook and also modify themselves. But we also have a lot of learners who hardly had any experience with Python. And so instead of having a 20-line of code how to visualize data with matplotlib, they start with a function and some keyword arguments, and this helps them also to modify some variables. Then also, and then just some simple but not always applied rules, like to import libraries at the beginning of a workflow, to make your format and code consistent, and also to use meaningful names for variables. So the fourth best practice is to take advantage of the full project Jupyter ecosystem. So I often get people coming to me and say, oh yeah, there's already a notebook existing. Then they send me the link to Github, and so our recommendation is just to not rely solely on GitHub rendering when you do teaching, and in the best case to make the notebooks available as a static content that allows learners to browse, but then also as an executable content. It can be an own training platform, or it can also be one of the free ones like Colab, Kaggle, Binder, etc. And if you're interested in how we use some of the Jupyter functionalities and projects in this training, what we developed, and there is another talk tomorrow about Jupyter for Copernicus. And the fifth guiding principle is aim for reproducibility, and this is at the same time also my conclusion, what I want to give everyone on the way. So we deliberately defined it as aim for reproducibility, because being reproducible is a big word, and so in particular, I would say it is very important when you work or when you use Jupyter Notebooks for training that you use the extra effort to try to use the extra efforts to make notebooks reproducible and also reusable, because this really helps you learners also to use the notebooks and benefit from them. And if the content is reproducible, it greatly increases the usability of notebooks. But I'm also aware that, especially when it's about data-intensive training, it's not only about making your notebook running from top to bottom. It's also to make data available and accessible, to give instructions on environment, dependencies, and libraries that people can also replicate the environment on their local machines. So I understand. So because also as an example from our notebook or training or developing training notebooks is usually we need 1 day of developing a draft workflow, and if in order to make it educational and at least reusable, it is another day just to clean up, to bring additional text, to think about how to break the workflow in different steps, etc. So it is reproducibility is really going the extra mile, but I really invite everyone who is using Jupyter Notebooks to going this extra mile from now onwards, because this in the end makes the notebook experience and use and the notebooks that are on Github really more usable and enjoyable. And with this, I'd like to thank you for your attention.
Thank you very much, Julia. And now if we have questions of anybody, I would really like to try this exercise, at least for this one session, to introduce yourself before you ask a question. Whoever manages gets PyLady stickers at the PyLady stand, so win-win. Okay, cool. So,
hello, my name is Tyler Erickson, so I get a sticker, I guess. My question, I guess, is on that last one for packaging versions. Do you recommend like pinning them so you're more apt to have a user be able to run it, as opposed to let them be unpinned, so that it might take on additional functionality in the future, and then the student would be responsible for like upgrading packages later on?
Yeah, so basically, because all the well, at least from our background, you know geospatial computations. So all the setup is quite particular always to specific package versions and Python versions, etc. And so with this, we recommend, or like at least for this reproducibility, the only way at the moment it works on, okay, this setup worked with this Python libraries and dependencies and with these versions of these packages. But there's always a need to also update it once it is tested. But often these packages are updated so frequently, at least as maintainers from the training content, at least from our experience, we can't update all the time when these when these libraries updated. So, but from every now and then, I recommend to update it. And then but I'm not sure if I answered your question.
Yeah, it is more, do you budget in that updating time for your training process? So if you have some course that you're going to teach over the course of years, are you thinking that you're going to have to update it every 6 months or?
Yeah, there is definitely. There is maintenance. Yes. So, for example, we are now in this way also that like we started with examples from 2019, 2020, but okay, they already now outdated, right? So there is also a need to go through this content, in a regular basis. Whatever is possible, 6 months is already tight and is a lot of time and work, but probably once a year. No, it's basically a combination of Markdown and HTML. Not sure if this is really readable, but so like the anchor links to navigate within a notebook, it's basically, yeah, you work with an HTML function that is called ID, and so you specify for each of the heading files in your notebook an ID, and then you can call this ID in your outline on top with a hashtag, for example. So there's this is probably not the it's actually here. So basically in a title you have here a ID, and then you call it section 1 or section 2, and then you can call this on top again with a hashtag and then section 1, and this is how you can link your titles and your outline.
All right, thank you very much.
Hi, thank you. My name is Joe Lucas. I'm from Texas. I thought the metric of text to code cells was really interesting. And so if you have more text or want to have more text than code, how do you kind of break up text in kind of sequential, if you have 3 text cells in a row, why is it 3 instead of just one big text cell?
Yeah, well, I think it's a good question. So usually, because you also don't want to overload the learners. So in the notebooks, from our notebooks, usually it's basically you have never, especially when you have when you are in the workflow and you explain steps, you never have huge descriptive text giving a lot of background. This is more really, okay, this is the step, this is what we do here. So really 2 to 3 sentences. And more text descriptive than at the beginning, but also we don't write books, so we really try to be quite precise and short in the explanations that learners also don't get overloaded. So I don't come often in the situation where I have, I don't know, a big text cell, but probably I would, if I have a big text cell, I would probably divide it in 3 paragraphs instead of having 1.
Hello. Hi, sorry. Thank you for the nice talk. I'm Arturo Amor. I work in Scikit-learn. And actually, in our library, we have an example gallery. And the original paradigm was to avoid as much as possible to add text. So to have a readable code that don't require text at all. So the idea was that people just tend to copy and paste the code and run them on their own. And a lot of text tends to scare people away, you get lazy if you see a huge paragraph. Nowadays, we are shifting this paradigm to add more text and more interpretation to the models, but still the ratio is definitely not 3:1, but I would say in the best case scenario, just 1:1. So 50-50. Would you say that it depends on the area of knowledge, this ratio that you recommend? Or because, I mean, in some cases you need more interpretation of each piece of code than some other scenarios.
I like to challenge this because do you always know how much interpretation everyone needs? No, so probably when we develop workflows, we always try to also bring ourselves into the shoes of someone who not has a lot of experience on Earth observation data. And so we try to start really from maybe not the basics, but trying to be really not assuming that, okay, everyone knows that. But I agree. So you have to choose. So you shouldn't overload people, but at the same time, we also need more text, and definitely not the recommendation what you got at the beginning that okay, code is understandable by itself.
Okay, we have a last comment.
Great. I'm Carol Willing. I worked on Jupyter Hub, that kind of stuff. But great talk. I'm really looking forward to reading the paper. Did you look at visualizations in terms of text versus code? We just talked 3:1. What I found in my training, at least, is some of that text, if you are embedding YouTube videos or embedded things, as well as having visualizations, I would group those sort of with the text cells.
Yeah.
Okay.
Yeah, certainly. I agree. Yes.
Great talk, though.
Yeah, thank you.
So, thank you everybody for your attention.
Thank you.
Yeah, you can